So for perfect substitutes, we're not really going to be able to use the Lagrange method to find our optimal consumption choice. And that's because we have a linear indifference curve. So there's not usually a tangency between our indifference curve and our budget constraint. So this yields what we call a corner solution, meaning that we're going to end up spending all our money on one of the goods. And that makes sense because here we have perfect substitutes. We can consume them in place of one another, so we just want to pick whichever one is best for us and just buy all of that one. So I want to show you here that the Lagrange method doesn't work, and then I'll show you how to find the optimal choice for this consumer. So we have a simple example with numbers where we have a utility function, 3x plus y, and some budget numbers. So let's go ahead and write out our budget constraint first. I've got 10 equals x plus 2y. And let's write out our Lagrangian. So it's good practice for us. We want to maximize with respect to both x and y. Our utility function is 3x plus y. And then we add on our budget constraint, rearranged so that it's equal to 0. There we go. Then we want to take the first order condition, meaning that we'll take the derivative with respect to both x and y and then set it equal to 0. So the derivative with respect to x is 3. And then we've got minus lambda. So we set that equal to 0. With respect to y, got 1 minus 2 lambda equals 0. Again, what we want to do is combine these by dividing. So I always just imagine I've moved my lambdas over to the other side, because they're always negative, so it's pretty easy to imagine moving them over to the other side. And then dividing, I get my marginal rate of substitution equals my price ratio. So this is my price ratio. This is my marginal rate of substitution. And you can see here that that's not true, right? 3 is not equal to 1/2. And so this doesn't work because my budget line is a straight line with a slope of 1/2, and my indifference curve is a straight line with the slope of 3, so there's no tangency between those two lines. So instead, what we're going to do is to find the optimal choice for perfect substitutes, we want to compare our marginal utility per dollar for each of our products and then buy the one that gives us the most marginal utility per dollar spent. Because marginal utility here is not decreasing. Marginal utility is constant, right? And so the marginal utility per dollar will be the same for every unit of X that I buy. It'll be the same for every unit of Y that I buy, and one is going to be higher than the other. So in this example, my marginal utility of X, that's just the derivative of the utility function with respect to X, is 3. And the price of X is 1. My marginal utility of Y is 1. And the price of Y is 2. So I can see that 3 is bigger than 1/2. And so I know that X is always my best choice. Every dollar I spend on X gets me 3 utils, right? 3 units of utility. Every dollar I spend on Y only gets me half of a util. So I'm going to want to buy X here. So buy all X. And then to figure out how much X I will buy, I can just look at my budget constraint, right? I'm going to spend all my money on X. And so that means that I'm going to spend right? Just do income divided by PX, and that gives me 10. And I'm going to spend none of my money on Y because it's not very good. So I'm not going to buy any Y. And that's my optimal consumption bundle in this example. The last thing I want to do here is to plot the budget constraint and the indifference curve so you can see what's going on. So for the budget constraint, remember, you just want to rearrange so that you've got Y equals something. So we've got, say, 2Y minus 10X. Y is equal to 5 minus 0.5X. So my y-intercept is 5, and my x-intercept is 10. Okay. The slope of this line is negative 1/2. The slope of my indifference curve is 3, right? So it's much steeper than my budget constraint. They're supposed to be straight lines. You can see the highest indifference curve, right, because my utility increases as I move this way. The highest indifference curve that is within my budget set is down here, right, at 10 units of X and 0 units of Y.